Welcome to the AME Food Testing Show. Today's topic, the use of acidifiers in controlling salmonella. Our guest, Nataliya Roth, Technical Manager, Biomin. Nataliya was born in Ukraine. She studied technology of meat products at the University of Veterinary Medicine in Lviv, Ukraine. She then moved to Austria to study food technology and biotechnology at the University of Natural Resources and Life Sciences in Vienna, Austria. For the past 5 years, she's worked as a technical manager for Biomin Holding. She's also worked on her PhD thesis about the reduction of antibiotic-resistant bacteria with the help of feed additives. Now welcome with me, Nataliya Roth, Technical Manager, Biomin. Nataliya, welcome to the show.
Thank you very much.
Would you like to add any additional information to your introduction I've just read?
No, thank you very much for your introduction. Everything was excellent. I do not have any additional information to say.
Very good. Let's begin. What is a food pathogen?
Foodborne pathogens are disease-causing microorganisms like virus, bacterium, prion, or fungus, and those contaminate food and may cause disease in humans. Foodborne pathogens are the leading causes of illness and death in less developed countries, killing approximately 2 million people annually. And in developed countries, foodborne pathogens are responsible for millions of cases of gastrointestinal diseases each year, and that costs billions of dollars for medical care. So bacteria are common cause of foodborne illness. Examples could be Salmonella, Campylobacter, and Escherichia coli.
Well, Nataliya, as we look at those human foodborne pathogens, what is Salmonella?
Salmonella is a foodborne pathogen bacterium and can be found in animals, humans, and in the environment. Bacteria of genus Salmonella are gram-negative, facultatively anaerobic, and non-spore-forming, and belonging to the family Enterobacteriaceae. And Salmonella serotype Typhimurium and Salmonella serotype enteritis are the most common serotypes found in humans, but many others have been shown to cause diseases. Mostly products of animal origin are the source of Salmonella: meat, eggs, unpasteurized milk or cheese, but also some from raw foods, vegetables, spices, and nuts may contain Salmonella bacteria. Many Salmonella infections are caused through the consumption of contaminated food. It may be raw, like undercooked food, or food that does not originally contain Salmonella, but has got contaminated through the contact with contaminated food. Salmonella is killing by the heat treatment, like cooking, pasteurization, and therefore it is important to pay attention on the proper cooking during the food preparation. Usually symptoms of Salmonella infection last 4 to 7 days, and most people get better without treatment. But Salmonella can cause more serious illness in older adults, infants, and persons with chronic diseases. Therefore, Salmonella with human foodborne diseases must be controlled.
Well, that begs a question, Nataliya. How can Salmonella be controlled in food?
Salmonella is a cause of bacterial foodborne disease in humans and can often be attributed to contaminated food products. It is estimated that around 30% of Salmonella infections can be attributed to poultry and around 50% in pigs. I would like to underline the importance of prevention of Salmonella occurrence in food. Taking as an example, meat. The prevention of Salmonella in meat starts with the prevention of Salmonella at the farm. Therefore, on farm Salmonella control is an important issue which is directly linked to regulatory limits at slaughter and public health concerns. Effective Salmonella control on the farm is based on the prevention of Salmonella entering and spreading in the farm. Salmonella is a common component of gut microbiota of animals, and therefore it can be found in the feces of affected animals. Fecal pollution is the main way for the contamination of feed and water with Salmonella. In order to ensure a high level of animal performance, farmers should pay close attention to farm management and Salmonella prevention. It is important to control all raw materials, implement good food hygiene practice in the production facility, and validate control measures to inactivate Salmonella if it already exists. Regular tasting and observing the critical points of the production chain. So maybe I can name some control points. The first one is the hatchery and breeder farms. So control starts with getting healthy young animals to the farm. On arrival, the chicks and piglets should be Salmonella-free. Samples from transport equipment and feces should be taken to determine the Salmonella status. Another control point is the control of feed and water in animal farms. So Salmonella is one of the major hazards leading to the microbial contamination of animal feed. Animal-derived protein and oil feed meal are the major sources of risk among feed materials to which Salmonella may be introduced to industrial compound feed. It is important to check all raw materials, especially cereals and protein sources, for Salmonella contamination. Yes, Salmonella colonies are naturally unevenly distributed in feed, and therefore their detection and qualification may be difficult. So the heat treatment of feed is actually the common means of feed sanitation, and it should be conducted appropriately in order to reduce bacteria counts, taking account in particular temperature, duration, and initial bacterial counts of feed. Acid treatments have a protective effect on feed, which reduces both the recontamination of feed as well as the contamination of milling and feeding equipment and the general environment. Salmonella can persist and grow within water. The diversity of concentration of Salmonella increases with the temperature rise in summer. And for better Salmonella control, the microbiological test of water is needed, especially if the source of water is well or river. Water for animals should have the same high standards as that which is suitable for human consumption. The results of 2 samples taken from start and endpoints of the watering line in animal production, and the difference between them, and it's actually a clear picture of whether improvements in water quality have been made or not. Another important control point is control of hygiene level and biosecurity. The contamination of the environment of animal housing can be a source of Salmonella infection too. Keeping building clean and disinfecting farm equipment helps to minimize the danger of infections. Improving farm personnel hygiene and the control of visitors are important factors for reducing the risk. Another control point is the proper vermin and pest control. Contact with other species may cause an infection to animals. The pests, rodents, wild birds, and other wildlife species have often been implicated as a potential source of Salmonella, and it has been recognized that flies also serve as potential reservoir or vectors of Salmonella. It is therefore important to ensure proper vermin and pest control on the farm. Another really important control point is the prohibiting of cross-contamination between animals.
So, Nataliya, what are acidifiers?
Acidifiers are feed supplements for poultry, swine, aquaculture, and other animals, and they contribute as organic acids. They are organic acids, inorganic acids, and they are salts. So single organic acids are used as feed preservatives for a long time, and the usage of organic acids as feed additives started and became popular in the 90s of the last century. And research on the usage of acidifiers was boosted in the late 90s and the beginning of 2000 due to the ban of antibiotics in the European Union. In the last years, the global feed acidifier markets grew by more than 5% per year, and the market analysts expect the same volume of acidifiers to rise beyond that in the next years. Research of last year showed also that the use of an acid blend is more effective than the use of single acids. Each acid has its own specific range of efficacy, and the composition of different acids has, of course, a broader spectrum of activity, and therefore it is considerably more effective than the acid alone. The more popular acids used are formic acid, propionic acid, citric, lactic, but as well sorbic, malic, acetic, fumaric, and phosphoric acid as anorganic acid. Now, the advantage of acidifiers is also their reduced corrosivity in comparison to the single acids, as acidifiers are buffered products with a higher pH level and therefore safer for workers and equipment. The danger of direct contact of workers with pure acids as dangerous substances should not be underestimated. Acids target both feed and gastrointestinal tract of animals. They start their work via feed reducing the pH level, buffering capacity, and microbial load of feed. And there is also the influence of acidifiers in the upper intestinal tract of animals. The pH-reducing effect of acidifiers in the stomach support protein digestion. A change in the upper digestive tract leads to a change in the lower digestive tract, like reduction of the pathogen load, improved digestibility, lower diarrhea rates, and better animal growth performance. And so the effects that can be seen when using organic acids highly depends also on which organic acid is used and at which inclusion level it is used.
Well, that's an amazing array of benefits from the use of acidifiers. How can acidifiers be employed to control Salmonella? It's the purpose of our call today.
The addition of organic acids has been shown to contribute to environmental hygiene by preventing feed raw materials and compound feed from microbial and fungal contamination. Acidifiers contribute to good farm management and interrupts the bacterial transmission in the animal to food chain. Acids are used, as I said, since decades to preserve feed ingredients and to control pathogens like Salmonella in feed. And control of pathogens in feed and water and better animal gut health contribute to lowering the environmental microbial load and contribute to enhancement of food safety. The mode of action, how organic acids act against bacteria, is well described in the scientific literature. So we know one part of acids is in the dissociated form and another is in undissociated form. And part of acid that dissociate releases hydrogen ion, and which reduces the pH value of the environment, like in water and feed, and creates unfavorable conditions for pathogenic bacteria. The strong bactericidal effect is achieved by the part of organic acids that do not dissociate. So undissociated organic acids penetrate through the membrane of bacterial cell and dissociate there due to the different pH level inside the cell. Bacterial cell pumps hydrogen ion out of the cell, and that makes the cell weaker because it needs energy for this process. The anionic part of acid in the cell disrupts the metabolism and DNA synthesis, which prohibits the replication of gram-negative bacteria such as Salmonella. So in general, acidifiers may be used for feed acidification and water acidification. Talking about feed acidification, there are many strategies for feed treatment, like heat treatment and use of acidifiers. those combination of those two strategies is required for the reduction of bacterial contamination and reduction of salmonella count and improvement of feed hygiene. Acid treatments have a protective effect on feed, which reduces both the recontamination of feed as well as the contamination of milling and feeding equipment and the environment. The efficacy of organic acids against salmonella depends on the level of bacterial contamination. The higher contamination, the higher should be the dosage of acids used. Acidifiers may be also used for water application, and this helps to prevent salmonella. A very important feature of water acidification is, of course, lowering the pH. The supplementation of acids in drinking water reduces the pH and also the bacterial count because of their changing the environment. And it is important to know that the pH level of water is known before we add acids, because if the acidification is too strong and the pH level of water goes below 4, this may have a negative impact on the environment, and animal will not drink this water, so it will have also negative effect on our water intake and growth performance of animals. But acidifiers are active not only in feed and water, but also in the gastrointestinal tract of animals. They act as antimicrobials also there. So unprotected acids are metabolized in the first part of intestinal tract, but the reduction of pathogen in the first part leads to the reduced pathogens number in the second part of the digestive tract. There are also some possibilities to protect acids. One of the possibilities is the carrier, and that prohibits release of acids and therefore ensures prolonged activity of acids in the gastrointestinal tract. And Biomin offers acidifiers on the sequential release media, and the trial showed that the acids composition on the sequential release media was able to reduce salmonella count in the gut better than the same acids without the carrier.
Well, that leads us into the question, Nataliya, what products does Biomin Holding GmbH offer?
Biomin offers sustainable animal nutrition products such as quality feed additives and premixes that include solutions for mycotoxins risk management, like product Mycofix, solutions for natural growth promotion with acidifiers, phytogenics, and probiotics, as well as other specific solutions which address dietary requirements for swine, poultry, dairy, and beef cattle, as well as aquaculture. Research and development is one of the cornerstones of Biomin. The strong in-house research and through joint projects with universities and research institutes, Biomin is constantly in touch with the latest scientific know-how. So science-based solutions address the health and the nutritional needs of animals with the aim of increasing animal performance in a natural way. Coming back to the topic of salmonella control, Biomin offers a special solution in form of a product Biotronic Top 3. And the successful control of pathogenic bacteria can be enhanced by combining organic acids with other natural-derived products, such as plant extracts, like phytochemicals, which are called phytochemicals, and Biomin Perforizer. This is a permeabilizing substance that increases the permeability of outer membrane of gram-negative bacteria. This is a new strategy in field of acidifiers and a very innovative concept in feed industry. Biomin feels this effective and unique product composition for the patent. So with the help of Biomin Perforizer, the antimicrobial effect of organic acid is boosted. The outer membrane of gram-negative bacteria, cell-like Salmonella belongs also to gram-negative bacteria, is acting as a protective barrier against external antimicrobial substances. And it is possible to weaken the outer membrane of bacteria by agents commonly characterized as permeabilizer. When permeabilizing substances weaken the outer membrane of gram-negative bacteria, the activity of other antimicrobials like acids and phytochemicals is increased due to easier entering of these antimicrobials into the cell and inhibiting or destroying cellular functions in the cell of pathogen bacteria. In the bacteria, the proteins and enzymes responsible for cell division are inhibited, which leads to the lethal injury of the bacteria. In this way, the perforizer provides a good precondition for maximizing the efficacy of other antimicrobial substances, boosting the efficacy considerably. So in general, it is worth to look into new strategies that give more force to acidifiers and enable the reduction of pathogens like Salmonella in animals and therefore in their products of animal origin.
Well, Nataliya, that seems to be a wider range of offering that Biomin Holding is providing, addressing the issue of controlling Salmonella. What is the optimum application and protocol for this product?
Acidifiers may be added to water or feed during compounding. So dosage is variable from 1 to 5 kilogram per ton of feed or liter per ton of water, depending on the age of the animals, on their conditions, and the hygiene status on the farm. So dosage depends also on the product, acid combination, acid concentration, and the availability of supporting substances like permeabilizer in the product.
Well, Nataliya, thank you so much for your time and your energy and your devotion to the use of acidifiers in controlling Salmonella. Would you like to offer any concluding remarks about our discussion today?
I would like just to say, to summarize, that Salmonella control in food starts with the prevention of Salmonella. So Salmonella control in products animals origin includes Salmonella control on the farm level. Proper farm management, biosecurity measures, targeting small groups of animals, and preventing the return of sick animals to the main production unit, that all contribute to the prevention of Salmonella spread. And using natural feed additives in feed and water minimizes Salmonella infection and promotes gut health and enhance the performance of animals. Natural feed additives like acidifiers can be seen as one of the management tools that improves animal growth performance and controls the growth of pathogenic bacteria such as Salmonella, which is a big problem in poultry and swine production.
Well, Nataliya, I'd like to personally thank you for your time and your energy, calling all the way from Austria, and your courteous and efficient use of these elements and the combination, as you said, in special combination to address the issue of Salmonella.
Thank you very much for letting me talk and participating in this interview. I enjoyed it very much.
And I'd like to thank you again and wish you a great day.
Thank you. Great day for you too. Bye-bye.
Bye.